Hello everyone, my name is Zhang Yuan. Today I want to introduce you our paper accepted by International Conference on Artificial Neural Networks 2023. The title is Reason as an Efficient Spiking Neural Network with Temporal Embeddings. And authors are from Peking University and Alibaba Group. Section 1 is to talk about the motivation of our paper. The event streams generated by dynamic vision sensor, as we said, DVS, are sparse and non-uniform in the spatial domain. While still dense in the temporal domain, it can generate 5 frames in 1 microsecond. Although spiking neural network, SNN, the event-driven neural model, has the potential to extract spatial and temporal features from the event streams, it is not effective and efficient. Based on the above, we propose an event specification spiking framework named Reason SN. Section 2 is to present about the core method of our math paper. As shown above, we present an event planning mechanism for the temporal domain by embeddings to adaptively filter out immaterial events and get the model slim. It would reconstruct features and predict attention vectors to compute the probabilities of dropping the events while retaining the event-triggered characteristics. And we get the planning architecture as Reason SN. The picture shows how event to plan for a spike layer in this model. Now, we first introduce the leaf model, a balance between complex dynamic characteristics and a simple mass form. Equalization 1 translates it to an iterative exploration with the Euler method. Equalization 2 and 3 express it how to update its neuron from spatial domain and temporal domain respectively. Equalization 5 is output of the neuron, response for checking whether the membrane potential exceeds the threshold VTH and firing a spike or not. Next, we introduce a set of learnable global temporal embeddings B to extract sequence principles on temporal features and weight the importance vector omega onto the temporal embeddings. Then the events of interest mask M can be obtained by calculating the similarities between weighted embeddings and the temporal frames in the feature maps. Eventually, multiplying with masks M, we reconstruct events feature and get the refined feature, which is a better substitute for original features. During the inference, we only need to send the refined feature to the adaptive max pooling 3D for extracting importance scores of temporal features S, and generate a binary mask M according to the scores will eliminate pointless frames which are lower than fleeting threshold STH we set, and set the attention scores of the other frames to 1. This is the reason planning architecture. We follow the recent state-of-the-art methods to use the X-stage pyramid structure. We introduce an embedding into each spiking layer except the encoding layer. The reason is that we assume that SN cannot extract more spatial and temporal information in this condition, and planning the whole network is to the unstable results. Section 3 is to present about experimental results of our paper. First, we compare Reason SN with various parallel work for event-based data. device gesture, and Caltech cipher on with like SNN method, spike-based SN method on above 3 benchmarks. Recent SN outperformed the strong baseline with a margin on cipher series and an Caltech 101 and achieves competitive performance on device gestures. The specific results are on the right side. The next is ablation studies. We perform experiments on device gestures to explore the effects of different numbers of temporal embeddings in recent SN. As shown in the left side, with only 2 embeddings, embedded proning improves SN by 0.84 accuracy, while more tokens could achieve further improvements. In this paper, we choose a number of 4 for better performance. We set experiments to show the contribution of each proposed component in recent SN. As shown in the right side, global temporal embeddings benefit most 0.131 for recent SNs due to its consideration of neighboring frames and extraction of temporal features. Embedding weighting module decides the embedding importance independently and provide a discriminative information and gains by 0.24. The refined feature has contained discriminative temporal information, and experiment statistics 0.1 proves that it's a better substitute for the original features indeed. Pruning eliminates with worthless events contain much more noise, which disturbs the essence model. The last is visualization analysis. We find the deep blue area of recent SN is smaller and more focused. This suggests that global temporal extraction is beneficial to handling the important region of intermediate channels. We observe that the pruning lengthens the color of the yellow area just with the background. The lighter the pixel, the weaker the spiking activate rate. Thank you for listening.